Good morning, this is Miss Cummings, and we're going to go over graphs and functions, topic 4-6. You're going to take a scenario, you're going to create a table, and then you are going to answer some questions about that table. The second part of it is you are going to be given some graphs, and you will need to interpret what the graphs actually mean. So, first example, a shoe store is having a sale. First pair of shoes sells for $40. The second pair sells for half price or $20. And sorry about that, I have alarm set to remind me what I'm supposed to be doing. And the next pair sells for half of that, and so on. So it asks you for making a table showing the cost of 1 to 5 pairs of shoes. So here we go. X is your number of pairs of shoes, and Y is your total cost. So if I buy one shoe, it says it's $40. If I buy 2 shoes, it's 40 and half off, which would be 20, which is 60. We'll make a little process table. This is total, and this is process. We'll do it that way. And then if I did 3 pairs, it would be the original and half of that and half of that, which would be 70. And then 4 would be 40 and 20 and 10 and 5, which would be 75. And then the 5th pair would be 40 and 20 and 10 and 5 and 250, which would be 7750. This is not linear. Okay. The next part, been working on this for a little bit, and remember when we can use 2 variables and we can say I have an X variable and a Y variable, and I can say that X is my input and Y is my output, and I can say X is my independent and Y is my dependent, and I can say X is my domain and Y is my range. There is a phrase that you should start remembering, because Y depends on X. When X is your independent and Y is your dependent, that means Y depends on X. This is a phrase that will help you determine some scenarios. So it says the blank depends on blank. Well, if Y depends on X, my Y is my total cost, and my X is my number of pairs. Okay. So if we were going to do a function, the function notation, so total cost is a function of pairs. So I can say write a dependent statement, and you would say total cost depends on number of pairs. I can say write it in function notation, and you would say the total cost is a function of pairs. The independent variable is always the X, so that's number of pairs. Let me scoot that a little bit up. And the dependent variable is total cost. Now, all of those questions actually came from this chart right here. So when you write this down, all of these answers come from you knowing the information off of this chart. Okay, total pairs, ordered pairs. I have 1 goes with 40, 2 goes with 60, 3 goes with 70, 4 goes with 75, and 5 goes with 77.5, and they are in set notation because that says that all of those belong to that set. Draw a graph. Make sure you have some information on your graph. Okay, make sure you have a title. So we're going to say shoe sales. Make sure you have axes and you label your axes. So I go 1, 2, 3, 4, 5. Make sure you have your title. So this would be number of shoes. Now your independent variable is always your x-axis. And then your dependent is always your y. So this is total cost. It could be labeled x. And then you could go 20, 40, 60, 70. And when I bought 1 pair it was 40, and 2 pairs was 60, and then 3 pairs was 70, and it starts trailing off, right? So it's kind of like this. And then the next problem, we have another scenario to graph. It says a balloon is being inflated with air. As more air is pumped into the balloon, the volume increases until it finally bursts. Make a sketch. Air, volume. I start with a deflated balloon. It goes up and then it bursts. So the volume depends on air. Y depends on x. X, y, independent, dependent. My independent variable is air. My dependent variable is volume. Didn't spell that very well. Let me fix that. Much better. And then y is a function of x, so the volume is a function of air. Okay, one more scenario. Let me get this situated so you guys can see it. Okay, it says for a certain time Lucy jogs up a hill at a steady speed, then she runs down the hill and picks up her speed. Match the graph to the situation. Okay, so I am going to label some things. This is a steady, and this is her speed increases. So this right here means time is going and her speed is constant. Okay, this says her speed is increasing for a certain amount of time, and then this says it decreases. This says her speed increases, and then she gets her stride and she keeps it steady or constant. So after I label the graphs, I'm going to go back and pick out which one it is. So she jogs up the hill at a steady speed, then she runs down the hill, which has nothing to do with it, and picks up her speed. So running down a hill actually has nothing, it doesn't show up on the graph. And so it is graph 1. Your assignment will be to read and interpret graphs. Make sure you pay attention to when things are steady or constant and when they are increasing. And make sure this is turned in by the end of the day. If you have any questions, please attend office hours.